Hi Honors Pre-Calc students, this is day 6 about trigonometric functions of angles. Okay, so today we're going to look at a lot from day 5 as review and then talk more about our unit circle. So if you remember from day 5, the biggest fact we learned is that any point on the unit circle, the x represents the cosine and the y represents the sine. And the reason behind this, because it's the unit circle, is that the radius is 1, which means the hypotenuse of our special triangles are 1 as well. Okay, so that's a little recap for you from the previous day. Then looking through, we have our trigonometric functions, sine, cosine, tangent, secant, cosecant, so cotangent, all the abbreviations, as well as referencing again what those would be in the unit circle. Okay, they have to be in the unit circle because the radius is 1. So here's another picture to reference it. We follow the formula. The hypotenuse is always 1. So x squared plus y squared equals 1. Your length, your height equals 1 squared. Turns out to be the equation of the unit circle. Centered at the origin, radius of 1. Well, based off what we talked about on day 5, if x is really your cosines and y is really your sines, then we know this identity. And that's shown here as well. Cosine squared plus sine squared equals your hypotenuse squared. Again, only in the unit circle because the hypotenuse is 1. Now, thinking about everything we just talked about, we're now going to look at the unit circle. So everything with the unit circle is based on the increments of our special right triangles. So this is the 30 degrees, 45 degrees, 60 degrees. All of those start at the x-axis and go upward. So notice that repeats in all 4 quadrants because those are the special triangles that we've talked about. Building lists, let's start with the xy axis. Again, the radius is 1, so this point right here would be 1, 0. Keep in mind the cosine of the angle and then the sine of the angle. So really, we're saying that this line right here, if this was my angle, starting here, end here, the cosine would be 1, the sine would be 0. Going to our y-axis here, that would be the point 0, 1, if I graphed it. So 0 is the cosine, sine is 1 of 90 degrees. Moving on to this point, the y would be x would be negative 1, y is 0, and then 0, negative 1. So those come just from going out, up, out, down of the unit circle. The next ones are our special right triangles. So I'm going to start with the first dot here, which represents our 30 degrees. And we're going to use special right triangles as a backup, but really we're going to look at small, medium, large. What I mean by that is starting always at the origin. 30 has the longest length compared to 45 and compared to 60. It goes to the right longer. If it's the longest, that means the x value is root 3 over 2. That is also directly from our special right triangles. Then our height, notice the height from the x-axis up compared to all 3 is the shortest. Well, the shortest height we know is 1/2. Quick check. Is the cosine of 30 root 3 over 2? Yep. Is the sine of 30 1/2? It is. So that's exactly where these values come from. Let's try the 45. So again, this will get us our 45 starting at the x-axis going up. Now this one's always a nice one. Whenever you're at the 45, so the middle dot, it's going to be the middle length. From the x-axis, you go out. This is to the middle. The middle length is always root 2 over 2. It's also the middle height, right? You're going up to the middle compared to 30, 45, and 60. So that would also be root 2 over 2. Anything with 45 is always root 2 over 2. The cosine and the sine. Your last angle is 60. Notice with 60, I'll put it right there, from the origin, you go out the smallest distance in your x. So your x is the smallest of all three. So I apologize. So the x is 1/2. The y value is the max, the longest. Compared to all three, it goes up the highest. Well, up the highest means √3/2. You can always double check by cosine of 60 is 1/2, sine of 60 is √3/2. Now some patterns to look at. It might be helpful if I maybe put a square root here and a square root here. The pattern of 3, 2, 1, 3, 2, 1 all comes into play. You can work on a way to help you remember, but for me, the easiest way is short, medium, long, side. Let's try setting up the second quadrant and see if it makes a little more sense. So I always like to start with the 30. Okay, that's the reference angle here. So if I go to the left, notice I'm going the furthest distance to the left. And if I'm going to the left, it's negative. Furthest distance is √3/2, going the furthest in the negative direction. My y value is the smallest of all three y values. I'm going up, so it's a positive 1/2. 45 is my favorite one. 45 is in the middle, so I go the middle distance to the left, middle distance up. One thing I have to remember is that I'm going to the left, so that means my x value is negative. But it's always the √2/2s, my favorite. Last one is 60. I go the shortest distance to the left. Shortest distance would be 1/2, but I'm going to the left. And then I'm the tallest y value of √3/2. This is repeated around all quadrants. You just have to notice if it's positive or negative based on your direction. So let's try a few examples and then we'll come back and finish up this unit circle. So when I am going through this, sine of 135, I'm going to locate that on my graph. Always starting at the x-axis, I go 90, and I go 45 more, and I would land right here. This is 135 degrees. Whoa. Degrees. I want the sine. Sine is my y. My y is the middle length. It's going up, so √2/2. So find your angle. Figure out if you're finding x or y, and is it small, medium, or large? In this case, it was the medium. Let's try cosine of 210. Start at the x-axis. You go 90, 180, 210 would fall right here. So label that point, 210. I want the cosine, which is the x value, and I notice I'm going the furthest distance out to my x value. Well, I'm going to the left, so it's negative. Furthest is √3/2. It's going to bug me, sorry. I'm going to make it perfect. I'm going to leave C for 1 second. I want to do one more example. Let's do D of negative 210. Well, a negative degree starts at the x-axis but goes clockwise. So I go negative 90, negative 180, negative 210 is actually right here, 30 degrees more. Negative 210 degrees. If I'm finding the cosine, that's the x value. And I'm going the furthest to the left. And since it's left, it's negative. And the furthest value is negative √3/2. Now the next three are all the fraction part. So tangent is really sine over cosine. In other words, you're doing your y over your x of 300. So let's graph it. start at the x-axis, 90, 180, 270, 360. Well, I need to back up 60 degrees, so I end right here. That would be 300 degrees. Now we need to find the x and the y since we're doing tangent. Well, if I graph it, I go the shortest distance in my x. Positive x, shortest distance, 1/2. My y is the longest distance compared to the 45 and 30. So the longest distance going down, -√3/2. Now please don't leave your answers like that, right? No fractions in a fraction. So the algebra there, if you divide by a fraction, same thing as multiply by the reciprocal. Cancels out the 2's. So you get -√3. Secant, hopefully you remember that secant is the reciprocal of sine. Put that on the bottom. Cosecant is reciprocal of sine. Secant is the reciprocal of cosine. A way to help you remember is that the letters are always opposite. C goes with S, S goes with C. And now we're going to find that angle. Well, sine of -225, negative goes clockwise. -90, -180, -225 actually ends at the same spot as 135, just in the negative direction. If I'm finding the sine is my y value. Well, if I'm at the 45, my y is always the middle amount. So the middle amount, 1/√2/2. I don't leave fractions in a fraction, so I'm going to put it down here. Instead, you can multiply by the reciprocal. And you would never leave a square root in the bottom, so please make sure you rationalize when we reviewed our trig. So 2√2/2 in the end is just √2. When you cancel out the 2's. Then cosine of -180, start at the x-axis, go clockwise. Cosine is the x. X here is -1. So it's really 1/-1, which is -1. You can always draw out your triangles and find your opposite adjacent hypotenuse. Hypotenuse is always 1. But we want to get to the point of short, medium, long, so it's more efficient with your unit circle. If you have questions on this, please make sure to ask in class. We will be going over this a lot, building the unit circle over and over. One last thing before I let you go is part G here. So I'm going to draw a quick picture. We have point P that's on the unit circle. That's really important that it's on the unit circle. And it says it's in quadrant 3. So quadrant 1, 2, 3. You can put it anywhere here. And it says the y coordinate is -4/5. You can even draw a triangle here if you want to look at it. It's a right triangle. Evaluate the 6 trig functions. Well, the 6 trig functions, review from the front page. Sine, cosine, tangent. Then I'll put their partners with it. Cosecant, secant, cotangent. And already, because we're given the y value, we are actually given one of the trig values. Remember, y is sine. So without doing any algebra, I know that the sine is -4/5, which means my cosecant is -5/4. Just flip the numerator and denominator. No math needed. Then we have to realize this is a unit circle, so the hypotenuse is 1, and the y is -4/5. Well, to find the x value, we've been using Pythagorean theorem. X squared plus y squared equals 1, the equation of the unit circle. We also can use our new fact of cosine squared. plus sine squared equals 1. Right? That's just from the front page. They equal the same thing. They mean the same thing. Well, I don't know the cosine. I'm going to be solving for it. I know sine is negative 4/5. Make sure we square it. And it equals 1. So doing some algebra. This is really 16 over 25. Move that over to the other side. You can change your fraction. Instead of 1, you can say 25 over 25. Square root. Cosine is plus or minus 3 over 5. Now, I always like you to put the plus minus so you can realize that, yes, it could be positive or negative. Based on this picture, because it's going to the left, you have to remember it's negative 3 over 5. Which that lets us create our cosine, because that's the x value. Our secant, which is the reciprocal. And now we're just left with tangent and cotangent. Well, remember from the front, tangent is the same thing as y over x, your opposite over adjacent. So when you're looking at tangent, y over x, the y value is negative 4/5, x value is negative 3/5, directly from our picture. Please don't leave fractions in a fraction. So multiply by that reciprocal. Oh, that crosses out pretty nicely. So you would get 4/3. Notice it's positive 4/3. And then positive 3/4 for the cotangent because you divided two negatives. So this is day 6 for you in a nutshell. If you have questions, please make sure to comment ask in class. And we're going to work on a unit circle for the rest of the chapter. Have a great day.